we're going to look at non-right angled triangles. The first trigonometry video was all right angle triangles, where we looked at Pythagoras and we looked at trigonometric ratios using sine, cos and tan, and we also looked at angles of depression and angles of elevation. So for non-right angle triangles, there's three things we're going to be looking at: area of triangle, the sine rule, and the cosine rule. Okay, so first thing you would always have to identify is, are you working with a right angle triangle or a non-right angle triangle? And once you make that decision, you're able to see, are you using Pythagoras, sine, cos and tan, or are you using area of triangle, sine rule and cosine rule? I think the hardest thing about trigonometry is that decision making at the start. I don't think the work itself is difficult once you've made that correct decision, because it's a lot of substitution into formulas and it's a lot of calculator work. But if you've made the wrong decision at the start, then obviously you're going to get the whole thing wrong. So just to note how we're labeling our non-right angle triangle. So we have our big letters or capital letters as the angles inside the triangle, and the sides are the smaller letters. And notice that capital A is across from small a, capital B is across from small b, and capital C is across from small c. That's really important. Okay, so first thing we're going to look at is finding the area of the triangle. So the formula for this is half AB and sine C. Now notice A and B are small a and b, so they're going to be the length of two sides, and C is a capital C, so it's going to be the angle, and it's the included angle, okay, which means the angle between the two sides. So for example, if we had A and B and we were trying to find C, if we had C and B and we were trying to find C, we would have to know the other side or the other angle. Okay, so it always has to be the angle that falls in between the two sides given in the question. So if we look at this example here, it says find the area of the triangle. We're given 46 degrees and we're given the length of this side as 7 and this side as 8. Now what you should notice is 46 is the angle between 7 and 8. So we are able to straight away start using the area of triangle formula without having to do some other work before we start subbing into the formula. So all we do here is half of AB is A times B sine C. So A and B here is 7 and 8. It doesn't matter the order. And sine of the angle is 46. And all of that goes into the calculator. Now make sure you check that your calculator is in degree mode. I'm putting that in. If you want, you can multiply all of this and then divide by 2 at the end, or you can put the whole thing into the calculator straight away. So let's do 7 times 8 sine of 46, pressing equals. So we've half of 40.2830, and then I'm going to just divide that by 2 on my calculator. So it's 20.1415, which is 20. So we're looking at units squared. Just remember, because it's area. Okay, now I know there was no units given in the question. There probably would be. If not, you could write 20 units squared. You probably wouldn't lose marks or anything for that at that point. So very straightforward, just substitution straight into the formula. And we'll just look at an example now where we're given the area and we've to work in reverse here. So area of a triangle is 40 centimeters squared. So first thing I'm going to do is write down my formula. Area equals half AB sine C. Don't worry about the notation. Like, I'm writing down sine C here, but we're trying to find angle A. That doesn't matter at all, okay? So don't worry about the way the notation is written or what letters are being used. It doesn't affect, obviously, the answer here. So we're now given the area and we're trying to find C. So we're going to sub in any information that we have at this point, and then we'll try solve this equation by leaving C, the angle, on its own. So the area we were given as 40, half of AB, and AB here is 10 and 14. And sine of the angle C, it doesn't matter if we write C or A here, just note that we're trying to solve this for the angle. Now, first thing I'm going to do here is I'm going to leave 40 here. Half of 10 times 14. So if 10 times 14 is 140, and half of 140 is 70 sine of A. Now, keep in mind here, this is multiplication. So 70 sine A is 70 times sine of A. So if I leave sine of A on its own for the moment, and I bring this 70 over to the other side, we end up with 40 divided by 70. Okay, now we've done this in using sine in the first video. When we're trying to find the angle and we've to move the trigonometric ratio to the other side, we end up with the inverse of sine, which is denoted by sine to the power of -1. Okay, and remember on your calculators, if you have a sharp calculator, you're pressing second function sine to get the inverse of sine. And if it's a Casio calculator, you're pressing shift and sine, and that will give you the inverse of sine as well there. So on my calculator, I'm using a sharp calculator this time, so I'm pressing second function sine, and you can see there it comes up as sine to the power of -1. I'm going to use brackets here just to be very careful. I'm going to do 40 divided by 70 because fractions are division. And when we do that, we get A equals 34.849. And it says here, find your angle to the nearest degree. So it means they want a whole number. So we need to look at the first digit after the decimal point. And because it's 8, we need to round that up to 35 degrees as the angle. Okay, so far that's fairly straightforward. We'll do one more example. So find the area of the triangle. Now this example is really important. So if we're finding the area, our formula is half AB sine C, but remember it has to be the angle that falls in between the two sides, or the included angle. So if we've 11 here and 9 here, that means we don't have the angle that we need to work out this question. However, we do have the other two angles, and if you remember in geometry, the three angles in a triangle add up to 180 degrees. So if I subtract 38 degrees and 48 degrees, that's going to give me the angle that I need to do this question. So 180 minus 38 minus 48 is 94 degrees. Okay, so this angle in here is 94 degrees, and now we have the angle included in order to solve this question. So the area is half. A and B is 11 times 9. Sine of the angle in between, so sine of 94. In our calculators, I'm going to do 0.5. I'm going to open a bracket. 11, close my bracket, open another bracket, 9, and pressing sine of 94. And the area is 49.379, which is just 49 centimeters squared. Okay. So just be careful with that one there. Often people would use the incorrect angle here, like they would just use 38 or 48 without thinking about the angle in between. So there are the three different ways that you could be asked to use the area of a triangle. So the first example was the most straightforward, where you do the two sides and you're given the angle in between. The second one is where you're given the area, so you have to end up using the inverse of sine here. And the third one is where you're not given the included angle. So first thing you need to do is work out the third angle in the triangle, and then you're subbing in as normal like you did in the first example. Okay, let's move on. The second thing that we're going to look at here for non-right angle triangles is the sine rule. Okay, now our formula for the sine rule is A over sine A equals B over sine B. Okay, in your log tables you will see it written with A, B and C, but the reason I've only written it using 2 is we only use it in 2 parts. Okay, so for you to use this, you're going to have to be given one side and one angle directly opposite, plus one other side or angle. Okay, now if we're trying to find a missing side, then we're using A over sine A equals B over sine B. If we're trying to find a missing angle, we use the same formula, but we flip the angles and sides. Okay, so I always try this first when I'm given a question and I'm asked to find the side or the angle in a non-right angle triangle. Before I try cosine, I try sine first because it's just slightly easier. And if sine doesn't work, then obviously you'd have to go on and use cosine. So remember here, you need to have one side, the angle across, and one other side or angle. So this example here says find the length of this side, which they've labelled x. So if you look at the question, you're given a side, you're given the angle directly across, and you're given one other angle, which means we can use the sine rule here. So I'm going to label these. So for example, for it to work with my formula, I'm going to call this side A. I'm going to call this capital A. I'm going to call this side B and this angle capital B. And we're going to sub into our formula. So we've A over sine of 62, because capital A was 62, equals B is 12 over sine of B, which is 34. So this is what you should have, 2 fractions, and you've your A that you're trying to find here. So when we have our 2 fractions, we're going to cross multiply. Okay, we're going to eliminate the fractions. And if we cross multiply, we end up with A sine of 34 equals 12 sine of 62. And remember, this is multiplication. So that's why we have our 12 in front of the sine of 62 and the A in front of sine of 34. Now the objective here is to try get A on its own. So if I leave A on its own, and remember I said this was multiplication, if we move multiplied by sine of 34 over to the other side, we get divided by sine of 34. Okay, so it was multiplied by sine of 34 on the left, and when we move it over, it becomes division. So if we're trying to find A, we're now going to put all of that right-hand side into the calculator. So 12 sine of 62, pressing equals, and then dividing by sine of 34. And on our calculators, we get 18.9476. So 18.9476, And I'm going to round this to the nearest whole number because in the question the other side was whole number. So that 9, because it's 5 or greater, is going to round this 8 up to a 9. So we're looking at 19 centimetres here as the length of that side X. Now the only thing I would like to point out here is that this is not the same as moving sine on its own to the other side and it becomes the inverse of sine, because that's only when we're trying to find a missing angle, and we had the angle here with that sine. So just be careful there not to confuse that. We're just moving multiplied by sine of 34. So when it moves to the other side, it's dividing by sine of 34. Okay. Another example here, it says to find angle A. Now remember I said if we're finding the missing angle, we flip the formula so the angles are at the top this time. So I'm going to label my information. We're trying to find capital A, which means that 14 has to be small a, and then 12 has to be small b, and 53 has to be capital B. So sine of A is what we're trying to find, over small a is 14, equals sine of capital B, which is sine of our angle, which is sine of 53, over small b, which is 12. Now we're going to follow the same principle here. We're going to cross multiply. So I end up with 12 sine of A equals 14 sine of 53. Now, remember this is 12 times sine A. I'm going to leave sine A on the left on its own for the moment. I have 14 sine of 53 on the right, and if I bring that 12, which is being multiplied on the left, if I bring it over, it's now being divided on the right hand side. And I'm actually going to put all of that right hand side into the calculator here. So 14 sine of 53 is 11.1808. I'm just going to leave it correct to 4 decimal places there for the moment. And this is where it's slightly different to the last example, because we're trying to find an angle. When we leave that angle on its own, and when we bring sine to the other side, remember it becomes the inverse of sine, the opposite of what we had on the other side. So I'm now going to have to put into the calculator second function sine, because remember we're looking for that power of -1. So when I put in second function sine, I'm going to open a bracket and I'm going to put in 11.1808 and I'm closing that bracket. Why did that happen? Second function sine, let me just see, 11.1808. Let me just put it in as this first and see does that work. So second function sine, 14 sine of 53 divided by 12. Okay. Is this incorrect? Let me just check this. 14 sine of 53 equals and divided by 12. Okay, so I forgot to divide by 12 here. So this is just 14 sine of 53. And I forgot to go on and divide by 12. So when I actually, just going to cross this out for the moment, what I should have here is sine of A equals, and when you do 14 sine of 53, press equals and then divide by 12 in your calculator, you should have 0.931741428. I should have copied that because the number was too large. We should be getting a decimal number. But also when you saw, like when I tried that 3 different times on the calculator and still didn't cop what was wrong, it kept coming up error 2. So I knew I had gone wrong somewhere, and that's why I went back up and checked here where the star is. So now that we have this, when I move the inverse of sine over, I'm then able to sub in 93174. Okay, so second function, hopefully it works this time. Second function sine, and in brackets I have 0.93174, closing my bracket, pressing equals, and remember we're looking for an angle here. So angle is equal to 68.707. I'm going to round it to the nearest whole number. So we've 68, and because this 7 is 5 or greater, it's going to round this 8 up to a 9, so it's 69 degrees. Okay, so they're the 2 different ways you can be asked to use the sine rule. First example was finding the missing side, and the second example was finding the missing angle. And the last thing we're going to look at in this video is the cosine rule, which is also used for finding, also used in non-right angle triangles. So our formula is a squared equals b squared plus c squared minus 2bc cos of a. Now all those formulas are in your log tables, so we shouldn't need to learn them off, and it's no harm knowing them, but you should be given your log tables or given a sheet with formulas on it in a test. So again, we're looking at non-right angle triangles and labeling them the same: the small a across from the capital A, small b across from capital B, small c across from capital C. Now, 2 times you're going to see this being used. So first of all, to find the angle where you're given the 3 different sides. And the second one is to find the third side when you're given the 2 sides and the included angle. Remember the angle in between again. So first example here says find the length of BC. And BC, remember I said they're the vertices. This means the length of BC. So they're the vertices, and we've called that A here. So if this is A, then 48 would be capital A, and then 6 would be B, and 8 would be C, but it doesn't matter if you had those 2 inverted. So I'm going to write down my formula. A squared equals B squared plus C squared minus 2BC cos of A. And we're going to sub in all the information here. So A squared is what I'm trying to find. So this is the easier version of the question. B squared is 6 squared. C squared is 8 squared minus 2 times B, which is 6, times C, which is 8, and cos of the angle, which is cos of 48. Now, what's nice about this version is you can literally sub all of that right-hand side into your calculator. Okay, so 6 squared plus 8 squared. Sorry, I'm going to go back there. Closing my bracket, squared minus 2 times 6 times 8 and cos of 48. And when we press equals, we get 35. And I'm going to write a few decimals here just to be sure. 35.76346. Okay, now we're trying to find the length of that side. If this is 6 and this is 8, well then it doesn't seem like this should be 35. It seems like it's far too long. So what you notice is you've a squared on the left. And if you remember in Pythagoras, the opposite to squared is the square root. So we're going to get the square root of 35.76346, and that will give me the length of this side. So square root 35.76346, and I got 5.98, which is centimeters, and nearest whole number would be 6 centimeters. So that means this is 6 and this is 6. So if you were thinking of your geometry class, two sides in a triangle, same length. So they could follow on with a question, you know, saying, what do you notice, or what type of triangle is this? And you should notice that's an isosceles triangle, because the two sides are the same, where we could assume the two angles are the same, also the two base angles. Okay, so just trying to think of the different links that you might have there. Okay, last question in this video. I'm still looking at the cosine rule. Because we're given, if this is A, it means that this is small a. Actually, we're going to use different notation here, and I'll explain why. So we're going to be finding this angle B, so this is small b, but technically in our formula, the angle and side that you're using have to be the one that you're trying to find. So technically this would be A, and technically this would be small a in your formula, okay? Which would mean this is B and this is C. Okay, so writing out your formula, a squared equals b squared plus c squared minus 2bc cos of A. So remember, we're trying to find the angle, so that's the B in this question, but we're just going to leave it as A. We have to write this side as the opposite to the angle we're trying to find. So this has to be 5 squared. And if you didn't have that there, you would be wrong. The other two sides don't matter, but this side and this angle do matter. So b squared is 4 squared plus 6 squared for c squared minus 2 times 4 times 6 and cos of A. And A is what we're trying to find here. So there's a little bit more work this time. 5 squared is 25, 4 squared is 16, 6 squared is 36, 6 fours is 24, multiplying these two brackets first, and 2 times 24 is minus 48 cos of A. 25 equals 16 plus 36 is 40, 52 minus 48 cos of A. I'm going to stop at this point here to explain. We cannot subtract 48 from 52 here, and this will be a big mistake we often see. This is minus 48 times cos of A. So that kind of has to stay as its own term for the moment. So we have 52 here, so we're adding 52 here. So when we have 25 on the left, we're going to bring plus 52 over to the other side, and it's going to become minus 52, and we're leaving minus 48 times cos of A here on the right hand side. So when we have 25 minus 52, we have minus 27 on the left equals minus 48 cos of A. Okay. Now at this point we can move the minus 48, but remember it's being multiplied by cos of A. So if it's being multiplied, when we move it over, it's going to then become division. Okay, so we're going to move minus 48, so we end up with minus 27, and minus 48 moved to the other side becomes divided by minus 48. So just be careful there. Remember, our sign is not affected. It's just multiplication becoming division. Now, from here, we have to move the cos to the other side. And remember, the inverse of cos is written as cos to the power of -1. And in brackets, I'm going to put minus 27 over minus 48. Now, second function cos, remember we're trying to get the inverse, so it's second function. I'm opening my bracket, I'm putting in minus 27 divided by minus 48. I'm closing my bracket and I end up with A equals 55.771. Nearest whole number, the 7 is 5 or greater, so it's going to round the previous digit up 1. So it's 56 degrees is that missing angle. Okay, and they're the two different ways. You're using the cosine rule. Definitely the first one is easier because you're just putting all of the right hand side into the calculator. That's to find the missing side. But to find the missing angle, it means that you need to just be careful when you get to this point where you have the number before the cos of A, that number is attached. It can't be subtracted here by the 52. Okay, so that's technically multiplied. So the multiplication becomes division. All of this cos moves over and becomes the inverse. And now you can put all of this into the calculator to find A. Okay, and that's your 3 different components to non-right angled trigonometry. So I'm going to send on some exam questions from that point.